Hello class, this is the last video for the review. Now, here we realize that this expression has to be greater than this expression. That simply means that the y values from here has to be greater than y values from here. So let us try to look into it. That means 2x squared minus x cubed has to be greater than x squared minus 2x. When does that happen? It happens. Let's try to look into this one. Then by putting everything onto the left side, we end up getting subtracting x squared, and adding 2x, adding 2x. We end up getting something like this. This becomes 0. Here we have negative x cubed plus x squared and plus 2x. Now, since just 2 have the leading coefficient to be positive, then we end up getting x cubed minus x squared minus 2x is in fact now less than 0. Now, when we factor this one out, we get x and x minus 2 and x plus 1 will be less than 0. Now these are three values where x equals 0, 2, and negative 1. So by drawing the number line here, negative 1, 0, and 2, since this one has a positive coefficient, as you can see here, then what's going to be happening is the sketch of the graph would be something along that line, and then we are looking for sections where things are negative. That simply means we are looking for this section or this section. Since A has to be 0 to 2, that works. 2 to 3, it doesn't work. Negative 1 through 0, that's also still positive, so our answer will be this one, choice 2 only. Alright, let's move on to the next question. Here we have double derivative. This is a great question. So when you take the first derivative, then what's going to be happening is 2y prime minus 3 equals 0. Now, the y prime now then becomes, by moving 3 to the other side, we have y prime now becomes 3, but divided by 2y. So that's what we end up getting. We have to take the double derivative. That means if you have to rewrite this one, this will be equal to 3 over 2 y to the negative 1 power. So y double prime then becomes 3 over 2 times negative 1 y to the negative 2 power multiplied by y prime. Since the chain rule idea is still implying, then we end up getting negative 3 over 2, and then y is on the bottom, y squared, but y prime here was this one, 3 over 2, and then y was on the bottom. So therefore our answer becomes negative 9 over 4 by multiplying these values, and then y cubed is on the bottom in the denominator. So there it goes. We have our answer, choice C. Now, next question. So h of x is given in this way. Now, what is h of 0? H of 0 means g of f of 0. Now, f of 0, we can see from here, seems to be 5. Then this is equal to g of 5. What is g of 5? Is equal to, in fact, 0 right here. But it says 4. That's not it. So that's out. H is increasing when x equals 2. H now that means increasing and decreasing is still related with h prime. So h prime of x becomes g prime of f of x multiplied by g f prime of x. Now here the value of x is equal to 2. Then let's look at it. We are looking at g prime of f of 2. F of 2 here seems to be 1. So we end up getting g prime of 1. multiplied by f prime of 2. But f prime of 2 seems to be negative. This one seems to be negative. G prime of 1 seems to be negative. Negative times negative must be positive, greater than 0. So therefore, this should be true. The graph of h is horizontal tangent at x equals 4. Likewise, okay, x equals 4, that means g prime of f of 4 times f prime of 4 is that in fact question mark equal to 0. F prime of 4 here is positive value, but f of 4 in fact is 2, so this last portion is equal to g prime of 2. But g prime of 2 is equal to 0, horizontal slope right here, that portion is equal to 0, which makes the whole thing equal to 0 due to the product. So second and third is true. Choice D will be our answer. Alright, now next question. The minimum distance. The minimum. It's like an optimization question. So from the origin to the curve. Now, then in this case, we are looking at a distance formula. How are we going to get the distance formula? Distance, when you simply sketch it, the graph will be something like this. Now, distance from the origin, then we will be looking at from this part. So let us say this particular point. Then how do you find the distance? D. Even though we can use the technically distance formula, I'd rather use the Pythagorean theorem where we have d squared. Distance squared is equal to x squared plus y squared. Now here, y in fact is e to the x. So in fact when we rewrite this one, this becomes x squared plus e to the 2x. That's what we end up getting. And then as you take the derivative, 2d times d prime is equal to 2x plus 2 e to the 2x. Now this one has to be equal to 0. What does that mean? It simply means that x plus, by dividing by 2, x plus e to the 2x has to be equal to 0. Now, you can graph this one, or you can, solve it using your calculator, but what I'm going to do right now is I'm going to just use this one using Wolfram. So here we have x plus e to the 2 times x equal to 0. When does that happen? Alright. Approximation for me. Okay, now, have we made a mistake? Now, in fact, that okay, that happened. We're looking for minimum distance. So then the value of x actually happens right here. Now, that happens around here, negative 0.42, blah, 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 blah. So then, what I'm going to do is this. We will use that value into the calculation. So then distance, if you remember, distance square was this. Distance squared was x value squared, so we're going to have negative 0.426303 square plus e to the 2 times this value negative 0.426303. Now, all we have to do is raise this one to 0.5. That will be our distance. We realize that it's about 0.78, as you can see. So our final answer would have been 0.78 right here. Alright, now, next question. Area of the first quadrant region bounded by y-axis. So we're looking at here. Y-axis, and then the line y equals 4 minus x. Y equals 4 minus x would have been something like this, where this is equal to 4, and that's equal to 4. Y-axis, we're talking about this one. And then the graph, y equals x minus cosine of x. Now, cosine of x would have been something along, let us say along this line somewhere. Now, we're looking for this section. Then what are we going to do? We're basically going to have to find the intersection first, right over here. And then we have to take the integral, obviously 0 through that particular point. Upper function would have been 4 minus x, minus the lower function would be x minus cosine of x dx. Now, using our calculator, we should be able to plug in these things and then get our answers. First, let us try to find the intersection between those two. So I'm going to go back to this one. Four minus x is equal to x minus cosine x. Intersection seems to be around there, about 1.858. I just used that, 1.858. Now, then here we get 1.858. Now we have to take the integral of this. So we have negative. Let's see if I can try to just write down integral of this from 0 to 1.858. Let's see if it works. Alright, it does. So the answer was 4.93, 4.94, so we end up getting 4. Okay, then it's about this value. Yeah. Alright. Approximately was equal to that value. Alright. Let's yep. Let us continue. The number of inflection points. Now, 0 through 5. So one thing that which we can do is, why don't we just sketch this one and then see what happens. Y equals 2 times x plus cosine of x squared. Maybe I just write down graph of where x is 0 to 5. Alright, so we have 0 to 5 right over here. Now, inflection point seems to be 1 here, 2, 3, 4, 5, 6, 7, and 8. It seems to be around 8. Now, we just have to make sure if there's an inflection, like, so there's a 1, change of concavity 1, 2, 3, 4, 5, 6, 7, 8. So our answer seems to be around 8 right over here. Now, the next question. The rate at which melting blah blah blah. Now, that's what's happening here. Now, what amount of ice has melted in the first 5 minutes? Then here we are actually looking at the integral 0 through 5 with the square root of 1 plus 2 the t. dt, all we have to do is just graph this one, and then we can get the area under this curve. In my case, what I'm going to do is this. Once again, integral of square root of 1 plus 2t. 1 plus 2t, from 0 to 5. Around 14.5. Alright, so our answer would have been around 14.5. I believe it was 3. So our answer would be this value. Alright, let us continue. Now, particle moves along the x-axis. So that the position is given by that value. And then now, for what values of x is the velocity of the particle increasing? Now, the question is velocity is not positive, no negative, but velocity is increasing. In other words, this we are talking about acceleration is positive. Now, acceleration from this graph is concavity. So essentially what we are looking at is concavity, positive concavity. That's what we're looking at, this one. So what we like to do is we like to sketch this one and then look for a positive concavity and see what happens. So once again, graph of y equals x plus 1 and x minus 3 to the third power. Now when I look at the choices, thing seems to be 0 through approximately 3. So I'm gonna say from -1 to 4 or 5. Okay. Now, where do I see positive concavity? I see positive concavity right over here. So I believe it's going to be around from 0 through 1-ish, because from here to here seems to be negative concavity. So 0 through 1 seems to be the answer. 0 through 1. Alright. But do we have another positive concavity? Yes, in fact, 3 and up is also has a positive concavity. So in fact, that seems to be okay. But also, this seems to be the better answer. So our answer would be that one, not this one. Alright, let us move on. Here we have f of x is given in this way. Now, g is the inverse of f. Now, that means, in fact, for if I were to write this one, reminder, for f of a is equal to b, then f prime of a would be 1 over inverse function for the corresponding value in this way, right? So therefore, the fact that the value, x value for g is equal to 3, then in this case, here we will have our result will be in fact equal to 3. So in fact 3 is equal to ln of e to the 2x over x minus 1. Now if you have to simplify this one, we get 3 times x minus 1 is equal to ln and e basically cancels out. We have 2x. Now then we have 3x minus 3 equals 2x. And we will realize that x is equal to 3. Now, then in fact we are looking at 3 and 3. So even here we just have to get the derivative of f prime of 3. And then we just have to get the reciprocal of it. So what is f prime? This portion can be simplified as a 2x. What we like to do is let's use the quotient rule. So the bottom is what? X minus 1 squared. Top is 2x over x minus 1. So when we take the derivative of the top, we get 2 times x minus 1 minus derivative of the bottom, which is simply 2x times 1, which will be that. And then when we plug in 3, in this case, we end up getting 2 times 2 minus 2 times 3 over 2 squared. Now this becomes 4 minus 6 over 4. Now which is equal to negative 1/2. Now, but here we have to get the reciprocal of that, so we will end up getting negative 2. Alright, next question. We have to get the integral of this one. Now, here if I were to rewrite this one, I'll be writing it this way. Because this portion is one fraction and this one is the other. So I'll be getting 1 minus 2x over e to the x squared dx. Now here we notice if we set u as x squared, then you will realize that 2x becomes its derivative. So here we have let u equals x squared du equals 2x dx. Using the u substitution, here we have 1 minus du over e to the u. Now, if you have to rewrite it, then this becomes 1 minus e to the negative u du. When you take the antiderivative, notice we'll end up getting here, oops, u, and then plus e to the negative u plus c. That's what we end up getting. Now, by plugging in everything back, we will realize oops, I'm sorry, I made a silly mistake here. When I supposed to separate them, but I didn't get to. So I will be starting from here once again. So I'm going to erase this portion. Okay, so sorry about that. Here we have 1 dx. And the second part becomes minus du over e to the u from the u substitution. Now, because the 2x dx doesn't affect this term, it only affects this term, that's why I have to separate those two. And previously I made a silly mistake, just continuing on. Here, so we have antiderivative of this one becomes simply x. Here we have, because this portion is e to the negative u, so we end up getting plus e to the negative u plus c. Now u was equal to x squared, so our final answer becomes x plus e to the negative x squared plus c becomes our final answer. Alright, so we have this one, I believe. Yep. And let us continue. How many critical points does this function have? Now, when you, in this case, when we try to take the first derivative, or we can simply, let's try to, since the exponents are pretty high, why don't we try to just take the derivative and see what happens. When you take the derivative here, we have 5x plus 2 to the fourth power times x squared minus 1 to the fourth power. Now, plus 4 times x squared minus 1 to the third power, and then we have x plus 2 to the fifth power. Now when we factor out whatever is common, here we have x plus 2 to the fourth power is common, and then here we have x squared minus 1 to the third power is common, and then also we then what's left here is 5 times x squared minus 5 from the first term. From the second term, we have plus 4x plus 8. That's what's left. Now, then, since we're supposed to get 1 and 0 from here, by setting this one equal to 0, then you will realize that we will be getting one value, but since it's the fourth power, so in fact the sign will not change. It's like a double root idea. So there will not be critical points from here, but there will be critical points because the exponent is odd. That means sign will change before and after positive and negative ones, plus and minus 1. We will have two values here. And also, if you simplify this one, we will have 5x squared plus 4x and then plus 3. Now, here, just to check what kind of root this will have, we could have maximum of 2, but let's just use the discriminant to check the answers. Discriminant is what? B squared, which is what? 4 squared minus 4 times A, which is 5, times C, which is 3. Now, but you will realize that this is easily less than 0. That means there is no value here that makes this one equal to 0. So our answer will be simply 2. Now, next question. M and B the real numbers, and let the function f be defined by blah blah blah. Now, here, if f is both continuous and differentiable at 1, then what's going to be happening? Now, this implies continuous and then differentiable. Differentiable basically means when we take the derivative, they have to be equal to each other. Secondly, continuous, that means when we plug in the values of x, they also have to be equal to each other. So let's go for the first one first. By taking the derivative and set them equal to each other, then in this case we get to realize from first one, 3b plus 4x must be equal to, here, second one, which is equal to m. But here x equals 1, so 3b plus 4 is equal to m. We get to find that one relationship. Now, then in place of m, we will place 3b plus 4. Then we will end up, and then by plugging in 1 for the continuity's sake, when you plug in the 1, we will end up getting first one becomes 1 plus 3b plus 2. Now that should be equal to, once again, in place of m, we're going to have 3b plus 4. And then plus, because when x equals 1, just left with the coefficient. So here we have this. Now 3b cancels out. Then we realize that b, it's got to be equal to, by subtracting 4 from each side, will be equal to -1. When b is equal to -1, then what is m? M then is equal to 1. So 1 and -1. 1 and -1. Choice B becomes our answer. Alright, so next question here. Here, this is what we have. Then the value, what is f of 2? F of 2 then is f of 2 plus 5 must be equal to 2 to 2, because in place of x we are plugging in 2. But no matter what this expression is, since the starting and ending point is exactly the same, this portion becomes simply 0. That means f of 2 plus 5 is equal to 0. That means f of 2 is equal to -5 here. -5. But what is f prime of 2? F prime of 2 is when we take the derivative of this, f prime of x. Now plus 5 disappears, and here when we take the derivative we get sine of pi x over 4. Now when you plug in 2 over there, then f prime of 2 becomes sine of pi times 2 over 4, which is simply pi over 2. Sine of pi over 2 is equal to 1. When you add them up, we get -4 to be our answer, choice E. And with that, we are done with the last video. And enjoy, and have a great time on the exam on Wednesday.